Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So we are going to solve the given problem in three ways of variation of parameters method in three parts. So we'll begin with part 1 in one video. So let's get going. Solve y double dash minus y equal to 2 by 1 plus e power x. Here we are given a differential equation of order 2. Here y double dash or y2 is nothing but double derivative of y with respect to x. Okay, we can ask the same equation as or y2 minus y equal to 2 by 1 plus e power x or d square y by dx square minus y equal to 2 by 1 plus e power x or d square minus 1 into y equal to 2 by 1 plus e power x. Okay, using variation of parameters method. So all these four equations are same. Given differential equation, y double dash minus y equal to 2 by 1 plus e power x. Consider as equation number 1, or we can write it as d square y by dx square minus y equal to 2 by 1 plus e power x or d square y minus y equal to 2 by 1 plus e power x. Now take y common from these two terms, we'll get d square minus 1 into y equal to 2 by 1 plus e power x. Consider as equation number 2, which is in operator form. Say f of d into y equal to some r of x, where f of d equal to d square minus 1. The homogeneous form of equation 2 is d square minus 1 into y equal to 0. Consider it as equation 3. Now we'll find the solution of this homogeneous equation using the auxiliary equation. Later we'll find the solution of equation 2 or the given equation 1, using the solution of equation 3. Okay, let's see. So the auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d equal to d square minus 1. Let's replace differential operator by m, so that we'll get f of m equal to m square minus 1, and the auxiliary equation becomes m square minus 1 equals to 0. So this is of a square minus b square form. We can write it as a plus b into a minus b. Now equate each factor to 0. From m plus 1 equal to 0, we'll get m equal to 1, minus 1, and from m minus 1 equal to 0, we'll get m equal to 1. So m equal to minus 1, 1 are the roots of our auxiliary equation, right? Therefore, the roots are real and distinct. Right? And we know that if two roots, say m1 and m2, are real and distinct roots, then the solution of homogeneous equation looks like y equal to some constant into e power 1 root into x plus another constant into e power another root into x. Here we are using C3 and C4 instead of C1 and C2 because I wanted C1 and C2 to appear in the last general solution. Okay, so we'll write C3 and C4. You can write any of the constants, I mean any constants, a, small b, C1, C2 or anything. Okay, fine. But here I am going to take C3 and C4. Well, now let's write the solution of homogeneous equation. The solution of homogeneous equation is y equal to 1 constant into e power 1 root into x plus another constant into e power another root into x. Then y equal to C1, sorry, it's C3, right? C3 e power minus x plus C4 e power x, right? So we got the solution of homogeneous equation, and using this we'll write the general solution of the given differential equation. So by changing the parameters or the constants with functions of x, we'll get the general solution of equation 1. Okay. Let y equal to a e power minus x plus b e power x be the general solution of one or 2. Both are same, right? 1 or 2. So here we have just replaced the constants C3 and C4 by functions of x, a and b, where a and b are functions of x. So we said that let y be the general solution of equation 1, which is nothing but y is solution of equation 1. So y can satisfy equation 1, right? So in order to substitute y in 1, we need y double dash also. So let's find y dash and y double dash here. Okay, already we are having y, so we'll find y dash and y double dash. We have y equal to a e power minus x plus b e power x, right? Let's now find y dash. Y dash equals to a e power minus x whole dash plus b e power x whole dash, right? This equals to, here we are going to apply the formula uv whole dash equals to u dash v plus v dash u. Now consider, since here a and b are functions of x, so we'll consider a as u and e power minus x as b, and we'll apply this formula here, right? We'll get a dash into e power minus x plus a into e power minus x whole dash, right? Plus here you'll consider b as u and e power x as v, then we'll get b dash into e power x plus b into e power x whole dash, right? This equals to a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x, right? Plus b dash e power x plus b into derivative of e power x with respect to x is e power x. From this we'll get a dash e power minus x minus a e power minus x plus b dash e power x plus b e power x. Let's write the terms involving a and b firstly. We'll get minus a e power minus x plus b e power x. Now write the terms involving a dash and b dash. We'll get plus a dash e power minus x plus b dash e power x. Okay, and let a dash e power minus x plus b dash e power x equals to 0, so that while finding y double dash, a double dash and b double dash will not appear, right? So here we'll put this 0, then we'll get y dash equals to minus a e power minus x plus b e power x plus 0. So from this we'll get y dash equals to minus a e power minus x plus b e power x, right? We got y dash here. Now we need to find y double dash. We have y dash equals to minus a e power minus x plus b e power x, right? Let's find y double dash, which is equals to minus a e power minus x whole dash plus b e power x whole dash, right? This is equals to minus of, here also we are going to apply UV whole dash formula, so we'll get a dash e power minus x plus a into e power minus x whole dash plus b dash e power x plus b into e power x whole dash, right? This equals to minus of a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus b dash e power x plus b into derivative of e power x with respect to x is e power x is equals to minus of a dash e power minus x plus into minus minus a e power minus x. See, if you want you can reduce the steps. Okay, if you are really good at remembering the formula or applying the formula, you can reduce steps, number of steps can be reduced. Plus b dash e power x plus b e power x is equals to minus a dash e power minus x plus a e power minus x plus b dash e power x plus b e power x, which is our required y double dash. Now we got y dash and y double dash, right? Let's substitute y double dash and y in equation 1. Substitute y double dash in equation 1. We get, so we have equation 1 y double dash minus y equal to 2y 1 plus e power x. I'll substitute y double dash and y here. I'll get minus a dash e power minus x plus a e power minus x plus b dash e power x plus b e power x minus y a e power minus x plus b e power x equal to 2 by 1 plus e power x, right? Then minus a dash e power x plus a power x, a power minus x plus b dash e power x plus b e power x minus a e power minus x minus b e power x equals to 2 by 1 plus e power x, right? We'll get here plus a e power minus x and minus a e power minus x gets cancelled, and plus b e power x and minus b e power x gets cancelled, and from this we'll get minus a dash e power minus x plus b dash e power x equals to 2 by 1 plus e power x. Earlier we got an equation, right, while finding y dash. See, while finding y dash, we got, or we considered a dash e double e power minus x plus b dash e power x equals to 0, right? Consider this equation as equation 4. Okay, I forgot there. And the equation obtained by substituting y double dash and y dash in 1 as equation 5. Now by solving these two equations, we'll get a dash and b dash. From that we'll get a and b, and later we can substitute that a and b in the general solution. I mean in general solution formula, I can say. Now let's solve equation 4 and equation 5. Now let's solve equation 4 and 5. A dash e power minus x plus b dash e power x equals to 0 minus a dash e power minus x plus b dash e power x equals to 2 by 1 plus e power x, right? So here we can cancel plus a dash e power minus x and minus a dash e power x, and here we'll add this, we'll get 2b dash e power x equals to 2 by 1 plus e power x. Then b dash equals to 2 by 2 e power x. Just take 2 and e power x to RHS, we'll get 2 e power x times 1 plus e power x. Right, here 2 gets cancelled and we'll get b dash equals to 1 by e power x into 1 plus e power x. Now substitute b dash in equation 4. We have equation 4, a dash e power minus x plus b dash e power x equals to 0, right? We can write the second term. We can take the second term to RHS, then we'll get a dash e power minus x equals to minus b dash e power x. Then a dash e power minus x equals to minus of b dash is 1 by e power x into 1 plus e power x into e power x, right? So here e power x gets cancelled and this equals to minus 1 by 1 plus e power x. Now take this e power minus x to RHS, we'll get a dash equals to minus 1 by, or it will be easy if you write e power minus x as 1 by e power x here itself. Okay, now we can take 1 by e power x to RHS. A dash equals to, if you take, or you can just write it as a dash into 1 by e power x as a dash by e power x. Okay, from this we'll get a dash equals to e power x by 1 plus e power x. Okay, so we got a dash here by substituting b dash in 4. So I forgot to write this minus. Now we are having a dash and b dash, right? Let's find a and b. First thing, I'll consider a dash. Okay, we know that a dash is nothing but derivative of a with respect to x, so we can write a dash as dA by dx equals to minus e power x by 1 plus e power x. Now we have to separate the variables. In order to separate the variables, I'll take the differential dx to RHS, then I'll get dA equal to minus e power x by 1 plus e power x into e power x, into dx. Here the variables are separable. So we can perform integration. Integral dA equal to integral or minus integral e power x by 1 plus e power x into dx. Since we know that integral f dash of x by f of x into dx equals to log mod f of x, right? If f of x equals to 1 plus e power x, then f dash of x will be derivative of a constant with respect to x is 0 plus derivative of e power x is e power x, which is equals to e power x. So this is of integral f dash of x by f of x form. So we can write it as integral dA is a equal to minus integral f dash of x by f of x is log mod 1 plus e power x plus integral constant say c1. Then, or we can write it as a equal to minus log of 1 plus e power x plus c1. Therefore, a equal to minus log of 1 plus e power x plus c1. Let's find b using b dash. We have b dash equals to 1 by e power x into 1 plus e power x, right? Now, we'll write or add and subtract e power x to the numerator. Okay, now consider 1 plus e power x as one term and e power x as another term. Now we are having two terms in the numerator and one term in the denominator. So we can split this as 1 plus e power x by e power x into 1 plus e power x minus e power x by e power x into 1 plus e power x, or you can use partial fractions method to split this fraction. Okay, this is equals to, here 1 plus e power x gets cancelled from the first term and e power x cancelled from the second term. We'll get 1 by e power x minus 1 by 1 plus e power x, right? Now we got b dash equals to 1 by e power x minus 1 by e power x, right? We can write b dash as derivative of b with respect to x and here we need to separate the variables, so we'll take the differential dx to RHS, then we'll get dv equal to 1 by e power x minus 1 by 1 plus e power x into dx, right? So here the variables are separable, so we can perform integration. Integral dv equal to integral 1 by e power x dx minus integral 1 by 1 plus e power x dx, right? From this we'll get integral dv is b equal to integral 1 by e power x. You can write it as integral e power minus x dx. Let's not perform integration here itself. Let's take time. Okay, so we'll get integral dv as b equal to integral e power minus x dx is e power minus x by minus 1 minus integral 1 by 1 plus e power x. See, here we are having 1 by 1 plus e power x, right? Just consider it. We can write e power x as 1 by e power minus x, right? Then just take the LCM of these two terms, we'll get e power minus x plus 1 by e power minus x. Okay, we can write it as e power minus x by e power minus x plus 1 or e power minus x by 1 plus e power minus x, right? So I'm not going to do or apply integration here. I'll apply integration finally. I'll apply formula finally. Okay, we need to simplify few things, so let's see that firstly. Then integral dv equal to integral e power minus x dx. I'll take this minus inside the integral, so I'll get plus integral 1 by 1 plus e power x dx, right? Then integral dv equal to integral e power minus x dx plus integral, just replace 1 by 1 plus e power x with e power minus x by 1 plus e power minus x, then we'll get minus of e power minus x by 1 plus e power minus x into dx. Okay, it's minus. We have just replaced 1 by 1 plus e power x with e power minus x by 1 plus e power minus x. This becomes integral dv equal to integral e power minus x dx plus integral minus e power minus x by 1 plus e power minus x into dx, right? If f of x equals to 1 plus e power minus x, then f dash of x will be derivative of 1 with respect to x is 0 plus derivative of e power minus x with respect to x is minus e power minus x, right? So we'll get f dash of x equals to minus e power minus x. So this integrand is of the form f dash of x by f of x, right? Since we know that integral f dash of x by f of x dx is log mod f of x, So we can apply this formula here. Then we'll get integral dv v equal to integral e power minus x dx is minus x by minus 1 plus integral f dash of x by f of x is log mod 1 plus e power minus x plus integral constant say c2. Then b equal to minus e power minus x plus log of 1 plus e power minus x plus c2, which is our required b, and already we got a. So now let's see general solution. Therefore, the general solution is given by y equal to a e power minus x plus b e power x. This equals to a minus log of 1 plus e power x plus c1 into e power minus x plus b minus e power minus x plus log of 1 plus e power minus x plus c2 into e power x, right? This equals to minus e power minus x log of 1 plus e power x plus c1 e power minus x plus into minus minus e power minus x into e power x plus e power x into log of 1 plus e power minus x plus c2 e power x, right? You can write it as c1 e power minus x plus c2 e power x minus e power minus x log of 1 plus e power x plus e power x log of 1 plus e power minus x, and here we are having e power minus x into e power x. We can write e power minus x as 1 by e power x into e power x becomes 1. So just replace it with 1, then we'll get minus 1. This is the required general solution. Or you can write few more steps. Just replace it with 1 plus e power x log of 1 plus e power minus x plus c2 e power x, right? From this we'll get y equal to, write the terms involving constants c1 and c2. Firstly we'll get c1 e power minus x plus c2 e power x minus 1 minus e power minus x into log of 1 plus e power x plus e power x log of 1 plus e power minus x. This completes the problem. So we have seen part 1 of solving variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye. So we can see part 2 and part 3 in the next videos. Okay, the other two methods.